Vehicles typically come with stock tire sizes, but it's not uncommon for owners to choose tires that differ from the original specifications. Changing the tire size can alter the tire diameter, which directly impacts the total driveline ratio. The driveline ratio is determined by the differential gear ratio and the diameter of the driven tires, and it indicates how many times the drive shaft must rotate to turn the driven tires once. In this video, we'll explore how to calculate tire diameter using a simple formula and see how the driveline ratio changes as a result. The question reads, the owner of a base model sedan has decided to install performance wheels and tires. The stock tires are P245, 55 R18, and the performance tires are P285, 35 R20. The final drive differential ratio of the vehicle is 3.70 to 1. Use the driveline formula to calculate the new total driveline ratio, considering the change in tire size. In order to find the new ratio, we need the old tire diameter, divide it by the new tire diameter, and then multiply that by the differential gear ratio, which in this case would be 3.7. So before we can use this formula, we need to calculate the tire diameter of the old tire and the tire diameter of the new tire. And we'll be using this formula to do that. Let's begin by finding the tire diameter of the old tire. Using this formula, I'll represent TD for tire diameter, and the tire width, according to the tire size given in the question, is 245 millimeters. We then multiply that by the aspect ratio, and the aspect ratio here is 55, or as we've learned in previous videos, 55%. But unlike in the previous video, where we had to change 55% to 0.55, for this formula, we don't need to do that. So we'll simply take 55 as it is and multiply it to 245. Then we divide it by 1,270, which serves as a conversion factor to inches. And the reason why we convert it into inches using this conversion factor is because the rim diameter, also stated in the tire size, is in inches. So we'll be adding to this 18. Let's go ahead and compute this with our calculator. So I'll take 245, multiply it to 55, then divide that by 1,270. We end up with that value. Then we add 18. We end up getting a tire diameter that is roughly 28.6 inches. Let's go ahead and do this again, but for the new tire. So we have TD is equal to, and the tire size is 285. That's in millimeters. Multiply to 35. That's your aspect ratio. We divide this by 1,270 just as before, and we add to that the rim diameter being 20 inches. Using our calculator, again, 285 times 35 divided by 1,270 plus 20 gives us an output that is roughly 27.9 inches. So by upgrading to these performance tires, we're actually decreasing the tire diameter by a little less than an inch. Now, before we use the driveline formula using these two values, I just want to point out that you can also find the tire diameter by finding the tire sidewall height, multiply it by 2, convert it into inches, and then add the rim diameter to that value. If you do that for both of these calculations, you'll end up with the same outputs. But it's better off just using this formula. Let's move on to the driveline formula. So our new driveline, I'll represent it as NDR for new driveline ratio, is equal to our old value, which is 28.6, and that's in inches, divided by 27.9 inches, and you can cancel out the inches unit, you don't even need it for this. Then multiply that by the ratio that was provided. That's the differential ratio of 3.70. We want our final answer to be to 2 decimal places as well, since this one is to 2 decimal places. Okay, so we take 28.6 divided by 27.9, and then we multiply this by 3.7. And we end up getting roughly 3.79, and that is technically 3.79 to to 1. Now, in case you're curious as to why this formula works, it's kind of like finding a portion of a base value. Now, our base value here is 3.7, and this part right here represents a rate. Multiplying your rate by your base value gives us the portion, which happens to be 3.79, and we expect it to be a little bit over 3.7 because this value on its own is technically greater than 1. But that won't always be the case. The fact that our driveline ratio increases from 3.7 to 3.79 means that the drive shaft must rotate slightly more, 3.79 instead of 3.7, to complete a full rotation of the wheels. This results in increased torque at the wheels, which improves acceleration, but the wheels will spin slightly slower relative to the engine speed. In other words, this change favors power over speed, which may slightly reduce your top-end speed. If you have any further questions about this calculation, please leave a comment in the comment section. Thank you so much for watching.